Yeah, what's new in Axon Framework 3.2? That's a question that I'm very often asked, even though the release notes are always nicely published on the website. But we don't always do a what's new in X.Y webinar, but in this particular version, there's a number of features that we had some very nice response on. So we wanted to be sure to share those new features with everyone. But before I dive into the new features, while preparing this webinar, I had a lot of déjà vus, and I wanted to share some of Axon's history before explaining what we've done recently and where we are going. So some of you may know that Axon Framework was accidentally started somewhere in 2009 with the very first commits of Axon as a framework in late 2009. Actually, the first commit in GitHub under the name Axon was done on January 19th in 2010. Before that, the framework had another name, and I leave it up to you to find out what that name was. We had our first production user also somewhere in Q1 2010, and most importantly, it wasn't me, or it wasn't even anyone I knew at the time. I was just contacted by a company in France that they were taking Axon or our framework in production, and that was very early stage. And essentially, them going into production gave me enough confidence to start using it in proper projects. So in the period 2010 to 2015, we saw a very nice increase in adoption, very slow, but adoption wasn't really our primary goal. It was a framework that we built for what we thought was a niche market. CQRS and event sourcing were not really hot topics at the time. Only a small group of hardcore idiots, I guess, were using it. But still, in 2015, we had about 5,000 downloads a month, and for us, that was pretty good. And then something happened until 2018, obviously, and we saw a dramatic increase in the number of downloads. Currently, well over 10 times, probably 14 times as much as we had in 2015. AxonIQ was founded on that little bump there. That was quite interesting because you see a little dip afterwards. So we thought, oh, we founded the company and suddenly adoption decreases. Fortunately for us, that was not the case. This was just a bracing ourselves for the next increase in downloads. At the moment, Axon has been downloaded well over 700,000 times. So that's a lot. I do suspect some people have downloaded it more than once, but still, it's a lot of downloads for Axon. Half of these downloads, or at least more than half of these downloads, have been done in the last 6 months. So that gives you an indication of Axon's popularity at the moment. And that probably has to do with our vision and strategy, where originally we promoted Axon as a CQRS framework for Java. That is how well, it actually started as a CQRS experiment for Java, but later, as we started using it in production and we dared call it a framework, it was the CQRS framework for Java. But we discovered that CQRS is not really the goal for many of our users. CQRS is more of a means to achieving that specific goal, and more importantly, CQRS is optional in Axon. You don't have to use CQRS and still be able to make very good use of a lot of the features in Axon. Even event sourcing is optional. So it was this framework for CQRS and event sourcing, but even without event sourcing, it makes perfect sense. And moreover, DDD is optional, right? You don't really have to use DDD, although fortunately we don't see many users that don't. I still think it's very sensible thing to do in the type of projects for which Axon is generally suitable. So nowadays, the vision that we have with the framework and the strategy that we're adopting has much more to do with Axon as a framework for what we call evolutionary message-driven microservices. You might have heard of event-driven microservices. There's a lot of hype around events and their potential. We don't ignore that potential, but we identify many more types of messages, well, not many more, two more types of messages other than events, namely the commands and the queries. And then there's that word evolutionary, and that's very important to us. And I have a small illustration of what that means. Just imagine you have an idea for a business model. So you have some mechanism that generates money. That is generally what it's a function that describes the business model. And nowadays it's very common to believe that microservices is the only way to solve that problem, or at least to address that business model. So what we hope to do is to go from that idea and then implement a microservices based system. Right. Now that is a very difficult thing to do, and many projects end up in very nasty places, sometimes death, fortunately not for the people on the project, but only for the project itself, or well, I'm not sure if it's better or worse. But many projects end up as a distributed big ball of mud instead of the well-structured, nice architecture that they had drawn as boxes and arrows and is shown on a picture on the wall. So our vision is slightly different. So we promote the construction of what we call a structured monolith. It's essentially a monolith in which all the components are well defined and are not interconnected other than using the command bus, the event bus, and the query bus. So all these messages that are between these components are abstracted via one of the three bus implementations or the three types of buses that Axon provides. That allows us to, as time progresses, when the non-functionals require us to do so, to extract certain components and start deploying them separately. Since they communicate via commands and queries and events over these buses, it doesn't matter where these components are located, right? So the blue component here that has been extracted can still send messages to the green, red, and purple components and vice versa. They might take a bit longer because there are some network hops to take, but still functionally it is exactly the same. And as time goes on, we are able to extract more components and start replicating components for performance reasons or for high availability or whatever the reasons are. We can decide simply to scale them out. It doesn't really stop at microservices. We also have ideas on how Axon would work in a more lambda style components where so the whole serverless movement. It would be very interesting for these components to run in a serverless environment where you really don't know how many instances are currently running, because in the end you don't really care whether the instances are, or how many instances are running. You mainly care that your events are being processed timely, as are your commands and your queries. And then how many components or how many instances of a component you need to be able to process these messages, that is something that a platform could take care of. So what is needed for this, this evolutionary approach is essentially what we call location transparency. It's not only what we call it, it's what it's called in our industry. And location transparency means that a component is not aware nor makes any assumptions about the location of the components it interacts with. And that is essential, because if two components are not location transparent, or their communication is not location transparent, then it's not possible to extract components anymore as separate modules. And we have found that that is a very useful strategy, and especially initially to save money on the first implementation, and only start scaling out when the team is big enough or mature enough in sense of tooling, monitoring, etc., to manage these distributed systems. Now, location transparency starts with good API design. Of course, that's not the only thing you need to do, but we have found that the using a message bus, so to say, with an API that either returns futures or uses callbacks is a very good way to enforce that decoupling, and that's of course what Axon 3 does by default. So there's a lot of emphasis nowadays on this location transparency. We use explicit messaging in Axon, and that is why in Axon 3 we have, or 3.1, we started adding the query bus as well. We'll have a look at that a bit later on. And another thing that's very important to us is the separation of the business or domain logic from any infrastructure logic. Right? We want these concerns to be completely separated first, and secondly, we preferably we don't want you to think about this infrastructure logic at all, because the infrastructure logic is just a way. It's just something you need to do in your project to be able to run your business logic, right? The business logic is the goal, and that is what most of you eventually make money with. The rest of it is just a distraction, and we want to at least separate the core from the distraction, and preferably also provide some components that you can just hook into your application to remove even that distraction. So what happened recently? I already mentioned one thing, but there's a few features that we added to 3.1, which was released in December 2017, so just a few months ago. One of these is context-aware upcasters. We've noticed that in some cases upcasting from n to 1 event is really difficult. The context-aware upcaster is given a context object which has a lifespan of a single stream of messages. So you can attach information to that context as you see certain messages come by, so you can remember certain information that you might need to upcast an event later on in the stream. We've added a token store implementation for MongoDB. So there was already an event store in Mongo, and we saw that a lot of applications use MongoDB to update view models. So they also wanted to have the token store in MongoDB. Not so much because it allows us to update tokens in the same transaction, but more importantly, just to prevent nodes from requiring another database that otherwise they would not require to store these tokens. In 3.1, we added an additional serializer configuration for events. So it's now possible to use a different serializer for events than you would for anything else. That has proven to be very useful, though not to cover all the requirements. So there's some more going on in that area in 3.2. And another thing in 3.1 is we now allow add command handler, basically static factory methods. So instead of putting the add command handler on a constructor, you can also put it on a static factory method, and that is a method, of course, static, that takes a command and returns an instance of the aggregate. So by the definition or by the signature of the method, Axon will recognize those as factory handlers. We also added the query bus, and we added the ability to do parallel processing on tracking processors. So the tracking processor was a new concept that we added in 3.0, but it only allowed for one thread to process events at a time. and currently we allow multiple threads to simultaneously track events. And it doesn't matter whether these threads are running on the same machine or on different machines. They will automatically make sure that every event is handled on exactly one thread at a time. So how does that parallel event processing work? Well, prior to Axon 3.1, we only had one processor, and in Axon 3.1, we allow multiple threads. So in this case, we would have a tracking event processor with 3 threads, and you see that events can be handled out of order on different threads, but on a single thread, events will always happen in the order they also originally happened, or at least were registered in the event stream, right? So you decide what the ordering requirements are on these events, and based on those ordering requirements, Axon will pick a thread to handle them. For example, if you have a requirement that when an order ID is mentioned on an event, then they must be handled in sequence, then Axon will look at the order ID, and events with the same order ID will be guaranteed to be handled on the same thread. And this way you can guarantee that events mentioning the same order are always executed or handled in the order they were added to the event stream. And I just noticed I'm completely overloading the word order, but I still hope that the example was clear. So in Axon versions prior to Axon 3, actually up until Axon 0.1, we only had support for the command bus for commands and events, which were distributed on the command bus or the event bus. And in Axon 3.1, we added the query to that. And this has to do with our, let's say, change in vision, so to say, or recognizing the fact that this explicit messaging is so much more valuable than anything else actually in the framework. So we added queries as explicit messages as well. Very similar to the command bus, we have a query bus and a query gateway. Now the big difference between a query and a command, for example, is that in a query it is the result that carries the most value. In a command it is the side effect caused by the command that has most value, and it may optionally have a side effect. But also queries have slightly different routing patterns in the sense that maybe you have a query that only goes to one endpoint, right? So very similar to a command, which always has one endpoint. But for queries, in certain cases, you want to do what we call a scatter-gather query. You want multiple components to be able to answer a query, and then choose a response based on the variety of responses received from each of those components. And currently, we're also working on a different type of query, but we'll get to that a bit later. So last December we have released 3.2. Is that correct? I think the dates, I'm not sure about the dates, but it was in March. Yeah, so there's a copy haste mistake in that slide. My bad. So in March we have released 3.2, and we've noticed that the query API needed a bit of improvement. So if you are currently using the Axon 3.1 query API, hopefully through the query gateway, but you'll notice that some of these methods are now deprecated. You should use slightly different methods. But there was a big limitations, especially in the use of collections as return types. The API didn't allow you to define collections of types, so you would need container types to essentially encapsulate a list or a collection of items. So in this example here, you would have a query done for a find card summaries response, and this is taken from our demo application, the gift card application. So there's this single response object that contains the data, which is the list of the things we actually care about. And on the query handler side, you would also have this handle and then find card summaries query, which returns a find card summary response. That is not very beautiful, and it forces you to generate classes that you don't really care about. And well, one thing that we are very keen on is limiting the things that you need to build that you do not care about. So in 3.2, we've added explicit support for collections. So we've added different methods. So the change on the query gateway is backwards compatible. So you can now query and then describe the type of response that you expect. So essentially you can say, I want multiple instances of card summary. The return value is not a list of card summary, but is actually a completable future of a list of card summary. So that allows you to do whatever asynchronous processing you would like. So we've made the gateway similar to the command gateway, but the query gateway is also async in nature. So you can define the type of information you want and then decide to wait for that. So in this example, there's a response.join, which forces the current thread to wait for that completable future to resolve. In other words, for the card summaries to have returned. Now on the query handler, we can just define a list of card summary instead of defining this container type. Axon will automatically detect that this is returning multiple instances of a card summary. You can also return an array or any type of iterable will work. As long as you declare an array or an iterable, Axon will recognize that as multiple instances of, and on the client it will always get a list of card summaries. So another thing, another feature that we've added that we had received many requests on, and this is something that required some custom coding in a lot of projects, is the replay. Now in Axon 3 we've always said, well, the replay doesn't really exist anymore, it's a reset. So why is this not called the reset API but the replay API? I will show you why. Still the action performed is a reset rather than a replay. But just imagine we have an event stream with a number of events in it, and we have a tracking processor that is handling these events. Now imagine that after the third event we trigger a reset, and this essentially means that the tracking processor forgets explicitly or on purpose forgets where it was. It throws away any token that it has and it resets itself to the start position. It would then again process all these events, and now it will receive 1 again, 2 again, 3 again, and it will receive number 4 automatically. But it will just keep on processing events as it would always do, except that now there's a slight change in the information you receive. And this will also work in multiple threads. So just imagine this tracking event processor 2 with 3 threads is processing events number 1 and 3, which is possible, right? Because event 2 is handled after event 1. And just imagine we're triggering a reset in here. It means all threads are being reset, right? All the tokens for all the threads are being reset. And in this case, we are getting 1 again, we're getting 3 again, and then we're getting 2 and 4 for the first time. So it is very much possible that an event that is a redelivery but is it has a sequence after an event which is not a redelivery, because events are not always handled in sequence. Now there's a number of API or new API features that we provide. It is possible that certain handlers do not allow a replay. Right? Certain handlers might cause side effects that you do not want to trigger when a message is essentially a redelivered message. Right? So in our example here, messages, so on tracking event processor 1, the one on top, events 1, 2, and 3 are redelivered message. That's why there's a little asterisk behind them. So they get this little mark that Axon uses to make sure that an event handler is not marked as do not allow replay. if an event handler is marked, that message will not be delivered to that handler, and we move to the next message. So the message is ignored completely. Additionally, we also provide an extra parameter on event handlers. You can pass in a replay status object. Essentially, that is an object that tells you whether or not this delivery is part of a replay, or is it a first-time delivery. And this allows you to selectively execute logic. Perhaps you're doing two things in an event handler. Might not always be good practice, so beware. But if you are, you might have different side effects, or even prevent all side effects if the message is delivered as part of a replay. And the third addition that we have made is essentially part of the reset. So as soon as the tracking event processor gets a reset signal, it will invoke all the reset handlers on any of the event handlers that it is processing events for. Right? So this reset handler is very useful to, for example, clear the state of a view model. Right? You're doing a reset, so you want to clear any state that you have here. So this is what that handler is for. That is executed in a transaction. So as long as all the reset handlers support transactional processing, all the reset handlers on at least on a single node are executed transactionally. So that is some information you get from replays, making it a lot easier to trigger replays. And we've noticed that the main reason to trigger a replay is in situations of blue-green deployment. So essentially, you would deploy a new version of an application, and that new application has a different view model, so you want to replay the processor on that specific instance. But that also means that you do not want to send queries to that application until it has reached the head of the stream, because it's currently processing information of up to 9 years ago. So the tracking processor status already allowed you to get the number of active threads and segments, right? There already was an API or a method on the tracking event processor to give you that, but that doesn't give you any information on how the processor is doing, on where it currently is in processing events. So right now we've added some a method that reports per thread or segment in the processor what the last process token is. Now tokens are a bit opaque, so it's not always possible to exactly see what is happening, but at least for monitoring tools you might be able to get some information out of them. There is also now a number of methods on tokens that allow you to see whether one token is further down the stream than another token, or does a token cover everything represented by another token. So you can, for example, wait for until the processor has moved further than a specific event in the event stream. It also reports the segment ID and the mask of the segment, and that is a combination of information you can use to make sure that all segments are properly being processed. It also shows you how many, what portion of events, what percentage, so to say, of events is processed by that specific thread. So a mask of 0 would mean it's handling everything, and a mask of 1 means it's processing half. A mask of 1 would mean it's processing 25%. But then the two most important ones are actually the ones that I haven't covered yet, which are the replaying flag and the caught up flag. So these are two flags that are set in different situations that are very useful to report, especially in blue-green deployments. So let me give you an example of that. So the method you can call on the tracking processor is processing status. and it returns a map of integer to event tracker status. Event tracker status is that object that reports the different aspects, and the integer is the segment ID. So that's in a single-threaded processor, that's always 0. When there's 2 threads, it's either 0 or 1, etc. So just imagine an event stream with three events in it. And we have a tracking event processor that is currently processing these events. Now, after processing event 1, the token that it reports on processing status would be 1. That is the last event it had processed. The segment here is 0, 0 because it's a single-threaded processor. So segment ID is 0 and the mask is 0. It is not in replay mode at the moment, so it's processing events that it is seeing for the very first time, and it hasn't caught up either. So it means that the processor is aware that there are events ahead of it, and it hasn't seen the head of the stream yet. Now, as it moves and as it processes further along the stream, and it processes token number 3, it will basically bump bump the head of the stream, so to say. So it will try to read some messages and detect that there are no messages after 3, and that causes the caught up flag to go to true. Now, as soon as we trigger a reset here, and let's imagine that event number 4 is processed now, is reporting slightly different status. So after processing 1 again, it will report token 1 again, and it will have the replay flag set to true. That is because it knows the last event that it had seen was a redelivery, and it still has some events ahead of it that are part of the replay, and it hasn't caught up either. That doesn't change until token 3 is processed. So even after token 3, it's still in replay mode, because it needs to ensure that it needs to see a non-replayed event before it can really make sure that it has gone out of replay mode. So after processing token 4, it knows that, okay, I've received all of the messages that are part of the replay, and in this case, that flag will go to false. And since it's always also at the head of the stream, the caught up flag will move to true. So those are 2 flags that you can use to detect status. Of course, these flags are reported separately for each segment, which means that you probably need to combine the flags for all the segments together. So you're only really caught up if all the flags report true, and you are still replaying unless all the replay flags report false. Right? That is essentially what you want to report. So moving to yet another configuration option. In Axon 3.1, we added, as I said earlier, we added the event serializer, which is very useful because it allows us to very precisely choose the type of serialization that we want for these events, because the events are something you store forever, essentially. We had the intent to store them forever, and we'll probably not. But still, that means we need to be very careful with the format in which we serialize. Axon 3.2 adds another level of serialization, because we've noticed that the generic serializer doesn't always make sense for commands and queries, for example. So the generic serializer is used to serialize anything that is not a message, essentially. In practice, those are snapshots, and you might say, well, snapshot event, isn't that a message as well? Yes, it might be, but in general, the snapshot is a serialized version of your aggregate, and the aggregate itself is not meant to be transported to any other node than the node that has put that message there. So it's not intended to be transported to other components, as are tokens, and sagas. The generic serializer defaults to the extreme-based serializer, and we have found that to be a very good default for these options, because essentially it allows you to store anything, and it will just work. You will not have to think about, you will not have to have any requirements on default constructors or special fields or getters and setters that you need to define. Then there's the event serializer that we also knew already, which is used to serialize events, mainly in the event store. The default is whatever you've defined as message serializer. So if you're not defining anything, it will default to extreme serializer again, which is not really recommended for events. Even though it can serialize anything and it's still parsable as XML, it is very verbose. So the messages tend to become quite large, and as soon as event structure becomes a bit bigger, which is not a good practice, but it has to happen in some cases, these XML representations typically blow to extreme proportions, which is not something you generally want. So here you can choose something that is, for example, JSON, slightly smaller, or even a binary format if you want to. And then we added the message serializer, which is used to serialize any messages other than events. So commands, queries, even replies to commands and replies to queries. And the reason you might want to set up a different message serializer is there's a lot of these messages going over the wire. So it might be very useful to choose some form of serialization that's a bit smaller. You still want to think about interoperability to some extent, but these messages aren't as long-lived as events, but still they need to be used in an interoperable environment. So that is something you might want to tune as well. So how do you configure these serializers? If you're in the configuration API, if you use the configuration API, there's now a number of methods. The configure serializer was already there. The configure event serializer was added in 3.1, and the configure message serializer was added in 3.2. And essentially the defaults are, so an event serializer is by default the message serializer, and the message serializer is by default the generic serializer. If you're on Spring Boot, you've got two options. One is to use bean definitions. The default serializer, you would want to mark that one with @primary, so that when there's essentially there's going to be multiple options available, and if you didn't specify what type of serializer you want somewhere, you should be able to get one, and that would be the generic serializer for this one. You can define a message serializer and just put @qualifier message serializer on it, so that the Axon components that just want the message serializer can automatically get it from the application context. And the same for the event serializer. Put a qualifier on it, and then you can define any type of serializer that you want to use to serialize events. But we've added a new way to do it, which is even simpler and also better than XML configuration, at least. Is just an application.properties. So you can do some YAML programming if you want, or blow up the property files. But you can just define here that you want to use Extreme as your general serializer. You want to use Jackson for messages, and maybe also Jackson for events. So you can define as properties. There's a few options here. Of course, the choice is limited, because basically you have to select them from an enum. But we found that in most cases the choice is Extreme or Jackson. So the supported values are Extreme or default, which in both cases at the moment will pick an Extreme-based serializer. You can pick Jackson as a value, and then you get the Jackson serializer. And you can even pick Java if you want, and you get the Java serializer And please do not call me if you get serialization exceptions. You have been warned. Java serialization does not have a good name out there. Fortunately, that's not all, and I'm not going to dive into all of these features that we have implemented. That would make the webinar slightly too long for us to manage. But there's a few things such as the add qualifier that is currently taken into account in Spring Bean injection. So if you have multiple beans that are eligible for injection, you can pick one using qualifiers. If you're using the conflict resolution API, there's currently an extra method that you can use to detect conflicts that gives you slightly more information about the actual conflict that was detected. More specifically, you get access to the events that potentially triggered or that triggered the conflict. We've added Spring Boot AutoConfiguration for metrics, so it's enough to add metrics to your class path, or at least the Axon metrics module, and you would get reports on metrics. We've essentially reinstated. So for some reason, this feature was lost after lost in the 3.0 release, but is a membership change listener for the distributed command bus. So if you use a distributed command bus and the connectors detect a membership change, that is usually a good signal to invalidate certain cache entries because they might be picked up by other components. So that is that feature is back. And lastly, also we allow aggregates of which the state is stored in a generic repository to also emit domain events. And domain events are slightly different compared to regular events in that they carry a sequence number and the aggregate identifier. Of course, the aggregate identifier had always been known. That is not a problem. But state-stored aggregates do not retain their sequence number. So currently we have a feature that the event store is able to report the sequence number that should be attached to domain events. So as soon as you use an event store with state-stored aggregates, you will still get normal domain events and are still able to track which aggregate published which events and then in which order. So those are the features of 3.2. Well, usually the question we get is, and what are you working right now, and when can we expect 3.3? And I'm not sure if I'm going to answer that. Oh, yes, I am. So some of the highlights that we are currently working on for the 3.3 release, which we expect late May, early June. There's a few major events in between that we need to attend, so we hope to be able to release it before the end of May. And what we are currently working on is subscription queries. That is one of the query patterns that I haven't covered yet. Essentially, it means that you can do a query, and instead of getting a single response and then losing connection with the responder, you can get updates on the response continuously. So essentially, you open a subscription query, you say, I am interested in the status of a specific entity, and as soon as that status changes, the event handlers there can send updates to specific subscription queries. That API will be part of 3.3 as well. We are going to add dynamic scaling of event processors, more specifically tracking event processors. So currently, even though you can assign multiple threads to a processor, you cannot change the number of threads on them. And also, if you start a new instance with that number of threads, there's no way to partially rebalance these threads between two nodes. And those are features we are going to add to the API of tracking processors. We have also added an API to allow an aggregate to be a factory for other aggregates. It is very common that aggregates, the creation of an aggregate requires validation, and typically that validation is performed by some other aggregate that decides it is currently legal to create an instance of something. So you can basically apply events to a new stream instead of the aggregate's own stream. We are also working on assigning sagas to existing processors. So currently sagas always run in their own processor. So if you assign a saga to a tracking processor, there will be threads only for that specific saga instance. In different scenarios for different reasons, that is not always what you would want, especially in systems that have a lot of sagas. It would mean you have a lot of threads if you want to process these reliably asynchronous. So right now we are working on making it possible to assign multiple sagas to the same processor, and even multiple sagas together with event handlers on the same processor, so you can guarantee that sagas and event handlers always work in the same transaction. We are taking into account that sagas are not capable or should not by default trigger a reset, and they should also not handle redeliveries of events, because sagas trigger side effects and you generally do not want these side effects to be triggered again. We take that into account out of the box. And something that has been coming for a long time but had proven to be quite a tough job is to create a connector for the Kafka as the event bus or on the event bus. So essentially, when you publish an event, it is published to a Kafka topic. That was the easy part, but also consuming events from Kafka and handling them in event handlers. In the end, Kafka is a means of transporting events from A to B, and having that as an event bus connector, very similar to what we already had with AMQP, is a very sensible feature, we thought. There's some more you can check on GitHub if you want to know more details on what we are planning for the 3.3 release. Then I would like to get your attention to something else that we're working on. That is the conference we are organizing on September the 21st in Amsterdam. This is our second conference, so after the success of last year, we've decided to do it again. And this time bigger and better. So it's our well, hopefully annual event-driven microservices conference. It is a bit beyond only Axon. So what we are doing here is to promote the event-driven thinking, not only in the code that we write, but also in the designs, in the architectures, and even in the organization. We have a number of very interesting speakers, such as Rose Miles. Fortunately, I was also allowed to attend and present something. And we have Alberto Brandolini, Matthias Ferraz, and many more that we will eventually announce. You can register already. I'm not sure if it's early bird, so blind bird has finished because we have published part of our program already. But as we start announcing more of our program, unfortunately for you, ticket prices will also slightly increase. So at the moment we have early bird rates. So if you want to secure your place there, be quick. And the last thing I wanted to mention, that is also something that has been changed in the last few months, is that we are working on some other products that work really nice together with Axon Framework, and that really promote this evolutionary message-driven microservices philosophy that we have, and that is together with Axon Hub and Axon DB. Basically, we call that to upgrade your experience, because it makes it gets a lot of the annoying stuff that you need to do to get an upscale system up and running. It takes that away from you. So essentially, you just you start up these the hub and the DB, and then you can scale out seamlessly. So Axon Hub is currently still in beta. It's in 1.0 release candidate 1, so it is feature complete. There's a few little things that we are taking care of, but you can already download it for free. And you'll notice it's a zero config. Basically, it provides zero config location transparency to all of your Axon applications. So there's nothing in Axon Hub that you need to configure. There's a few things that we would recommend for a production environment, such as security and transport layer security. But other than that, the applications themselves automatically report which commands they can handle. When they send a command, Axon Hub will automatically route these commands and queries and events to nodes that can handle them. And it provides elastic scalability, so you can just add nodes, shut them down again, and Axon Hub will automatically transfer messages to corresponding nodes. It will also give you some insight into your application structure. So you can, it will inspect the command handlers that you have, the event handlers and the query handlers. On the tracking processors, it will report on its progress and things like that. In the future, so because Axon Framework doesn't support that yet, but Axon Hub will also manage these tracking processors. So it will automatically scale processors up and down as nodes become available or disappear again. And it will make sure that the load is properly balanced over all available nodes handling events. And together with Axon DB, which is currently in a 1.2, so that one has been out for a while. It's also used at several clients already, and it's a very fast and reliable storage of very large event streams. So it's been designed to quickly access events, even though streams are only growing over time, making sure that the recent events are very fast to receive. So it's really optimized for the use case of event sourcing. It's a very poor database if you want to use it as a relational database, and that's by design. So with that, that essentially concludes the what's new and what's coming in Axon 3.2. And let's see if we have any questions.